So I will show the result for section for then I will show the collection and then I will explain what are those. In QA random inspection, we do something like this. This is the inspection. What they do is they select style number. The number means order number of the product. And then they select color. And also they select report type. The type of reports. One, you can neglect this first output. Inline showing and inline finishing. This inline showing we call as QC1. Uh, inline showing means I think you are not familiar with this word, right, Mia?
Yeah, yes, sir.
Yeah, because of that, I will write for you. So otherwise, you may not remember. So in there are two types of report. These are the two type. What type? QC1 and QC. That means there are two checkpoints. For the QC1 or QC2, they do the inspection. So when they do the inspection, the date is automatically selected. That is the inspection date. So you also need to also inspection date. Inspection date. Then they select style number. Style number mean what is the order number the factory decide. There are two things when we consider style number. There are two things. One of the number mean it is decided by the factory, and then these orders coming from the buyer, right? So when they also have style number, but it is that style number is the customer style number. After that, we convert into one of the factory style number. We call that one as MO number. Or else sometimes they call style number also, but mostly we call as MO number. It is something like this. PDCOC 56, GPAR 11345, PTRT 2345, and GPAF 11, maybe 6004, something like this. Here also have important thing to consider. You see, I write PCOC, then GPAR, PTRT, GPAF, right? In this style number, there is special things included. You can see the first one includes CO, right? Letter CO is included, right?
Yes, sir. Yeah.
Yeah, it includes CO. In that case, we can consider this kind of style number as Costco style. This one, the buyer, we can say Costco. I think in this collection, as I remember, I see the buyer also. But this one also in your data pre-processing part, try to include function to identify the buyer on the MO number also, because it's important too. So the second one, AR include, right? If this letter include AR, that means the buyer is Arisha. And the third one, letter RT include, so that's buyer is Red Mars. And the fourth one, letter AF include, so that buyer we call as ANF. ANF. Sometimes we have style number like this, PTCOM let's say 355. So this one, you see, it includes letter COM, right? So that case we consider as AMWW. These are the 5 buyers we have. We have 5 buyers. Costco, MWW, Arisia, Rateman. So these two special, you can see it includes COC, right? It's not always COC. It can be either COU, COR, like this. COU, COR, COX, COT, sometimes COC, most of the time COC. It can be any of these. Not only these 5 also, it can be any of these. In this case we consider Costco, but if it includes CO and M, it is MWW. Other bias is always okay. AR, Arisia, RT, Rateman, AF, ANF. That logic is clear to you. This one we call as buyer logic. So we can get a buyer name based on the style number like this, based on the MO number. Like that is okay.
Yes, sir. Got it.
Okay. Yeah. So then there is another thing called customer style. This one is the given by buyer. Given by buyer when they place the order. So this one we don't care much about this one, but we can get this customer style based on the MO number. For each MO number has one customer style number. Okay, then there is a they need to select color also. So each style number can have more colors. Color. One, we can say one MO number now can have multiple colors. But sometimes it's like this, right? Let's say we consider 2 style, 35 and then PTC on 355. Those 2 style number can have color also, like black color, both color available for those 2 style number also, right? So then they need line number and size. Okay. It's like this. So the line number like this. Yeah. I will spend that one also. The line number, we have 2 things, line number and table number. So line number is coming if the report type is QC1, that's mean inline sewing, then line number. So this one report type should be QC1. So then we have line number. And then we have table number if report type is QC2. That's mean inline finishing. QC2. Also note that we don't save as QC1, we save as inline sewing. You can replace inline sewing mean QC1, inline finishing mean QC2, right? So this is like this. So the line number, we have sewing lines. There are 30 sewing lines available in your class now. 30 sewing lines. So it's start from 1 to 30. So this is also important thing, because if you ask something like this, give me all of the information in line number 31. So you need, in your chatbot should be able to say, okay, we don't have that line number. We have line number available from 1 to 30. That is also important, right? That's why I explain everything to you. And then we have size also. Size means consider some color. if you consider one color, it can have multiple size. One color can have multiple size. Multiple size. Like extra small, small, large, medium, XL, like this. Not only this, we actually, I think we have very close 100 type of size. So you don't need to get everything, but the size is also optional in the for this report. So sometimes it can be empty. So it's not so important, but we save this size as array. And then we have total check quantity. For this to report, this total check quantity mean it is the sample size. You can say as sample size. So in this report, what they do is QC. This report is done by QA. Also, there is another paper called QC also, right? QC mean they do inspection in the sewing line, also in finishing area. So when they do inspection in the sewing line, they check all of 100% garment. Let's say one line has for one day they create 1,000 garment. All of these 1,000 garment checked by QC. Sometimes it may be more than one QC for one line. Sometimes two QC for one, three QC for one line. Those three QC need to check all of the garment. But QA only check 20 sample from that garment. I'll explain also. You need to write that one also. So then you can refer this, right? Yeah.
Yeah, yes, sir.
Yeah. Because you need to know about this before you build this. So there are two people for this report is QC and QA. So QC doing 100% inspection. 100% inspection in sewing line or sewing line. If they do is sewing line, we call them as QC1 or finishing area. If they do it in finishing area, we call them as C2. They check 100% garment. Example, so if output for one is 1,000, they need to check all. Then this QC also do inspection, right? They all find some defect. So let's say they check 1,000 output and then they found 40 defect, right? So they also need to find defect. They also need to find defect. Let's say they check 40 defect, example 40 defect. Let's say this 1,000 output also only checked by one QC, okay? Can be multiple QC. So then that QC is 40 defects. So then that QC assume all of other 960 pieces is okay, right? So the QC said all of other 960 pieces is good gamma. But it,
So why only 40 defect?
no, I just example, right? Not every time, not only 40, just example. Okay.
Got it, sir.
Yeah. This 1,000 is This example, right? Example. And this 1000 can check by multiple QC for one. Also, I consider as one QC check 1000 pieces, and then that QC find 40 defect, right? Okay.
Got it, sir.
So then 900 that QC said all of other 960 pieces is good garment, right? But that QC can miss some garment, right? When they check some of the garment, they can some of the garment can miss, right? So then they come into this job, and then this QA check 20 random sample from this 960 pieces, because QA also cannot check all of 960 garment because he doesn't have time. He only check randomly select 20 pieces from this 960 pieces. So then QA 20 pieces randomly from these 960 good garment, and then this is our uh, inspection. So we call as QA random inspection, right? That is the one we do, and we call as QA random inspection. So our purpose is to find who are the best performance key based on this 20 random pieces check. Understand? So the goal of this one is to say who are the best performs QC based on this 20 random sample checking. Okay. So now you have understanding about what is doing here, right? Yeah. Any problem?
Yes, sir. Got it.
Yes.
One more question, sir. Who the target user of the chatbot? Who will ask question?
So this chatbot can use for QC and QA both, and also this chat is going to use by the managers, QA manager, and then the assistant manager, also the other top management team, including GM also. They need to know about who are the QC doing best, or what is the issue with the QC, who are the QC performs worse, like that.
Oh, QC also can ask or just no need.
QC should be able to see. So if QC wanted to know how he's doing, so then QC also need to see what is his risk based on his inspection also. So QC also a user of this chatbot.
No, sir.
Yeah. So the users all QC read only for this, right? Because when we consider QC, it's not only QC1 and QC2, there are other QC also. This is all QC means QC1 and QC2 only. And then QA and QA management team, and also top management if they wanted to know. Okay. So then this is what we're doing. So they select 20 pieces. So 20 pieces they can edit, but they only check 20 pieces. And then after they check these 20, they do something like this. Okay, I will select something here. They need to defect based on this 20 sample. So they select defect. So when they select defect, they check 20 pieces. One garment can have multiple defect also, right? and one garment can have one defect or multiple defects. So they can enter, like if they want to enter another defect to the same garment, they can enter that one also. And also when they select defect, they need to take a decision. These decisions coming automatically from one of our collection, so that they are based on this decision they can select. Then we consider there is a status related to each defect. If they select this unrepairable, so we consider that decision as critical. So let's say if we get another defect, skip stage. So now there are two decisions here. If this decision is minor defect, and if they select this one, it as major defect. So the defect have a defect status. Right? Okay, then I will write that one also. QA need to check defects of these 20 sample. So when select defect, they need to consider a decision, and then based on that decision, there is a status. For this defect, there are three types of status, right? Defect has three status, three defect status. Those are minor defect and major defect and critical defect. So based on this minor, major, or critical, we give some weight for each defect. If it is minor defect, we give weight as 1. If it is a major defect, we give weight as 1.5. If it is a critical defect, we give weight as 2. The weight of defect. So then they select 20 sample, then they need to select each defect, they need to get the decisions, right? So I will write that one also here. This defect status based on decision. Right? That decision also coming from one of our backend. So that decision automatically came from backend. So I will show that collection also. This one okay, right? It's clear.
To
select decision. Also, they can see the quantity also can increase. That means if there's defect of this garment, there can be two defect, right? Not only one place. Let's say the two places can have same defect, right? In that case, they can increase quantity also. Okay. So the QA need to find how many defects. How many defects. So then based on this, we calculate a pass rate each QC. So we calculate pass rate. We calculate it like this. I'll show it using example, right? Let's say QA sample size, that means check quantity is 20. Sample size is 20. Then he reject pieces is, let's say 2. For defect quantity is, why it happened? How do you understand why it happened? Because one garment they can select two type of defect also. So that means they reject only one piece, but there are two different defects. Yeah. Is clear or not?
Not sure that.
So it's like this. You see, then when they are defect, you see the garment one defect. So let's say this is the first pieces they select as defect, right? So that one they can select defect and they can take decision, and based decision the status is coming automatically. But they see there is a skip stitch in the same. So in that case, they can add another defect for same garment.
Got it, sir.
So then now how many reject pieces? Only one, right? Only one garment. But how many
Yeah.
defect? Two.
Two defect.
Yeah, two defect, or maybe it can be three. Oh, there's something. Can you see screen?
I see the screen.
Yeah, we stuck. Something. Okay. So then let's say this example. So two reject pieces, but three defect, and this three defect coming from the based on decision, we have something like this: one minor, let's say minor defect, two, and major defect, one. This is based on because they need to select decision also. Sometimes there is no decision for some defect. There is no decision. We consider directly status based on our collection. I will show that collection later. Okay, so now I want to calculate this pass rate. So we do like this. So there are three defects, right? Two minor defect and one major. So we need to find the weighted defect condition. How do we do this? Two minor defects. So we multiply 2 by what is the minor defect weight is 1. And then major defect quantity is 1. We multiply by weight of the major defect 1. So 1 multiply 1.5. So this value is how much? 2, 1.5 is 3.5, right? Then we get pass rate like this. Pass rate is equal 1 minus 3.5 divided by check quantity 20. How much is this? 2 and 1.5 is 3.
It's -2.
Okay, 2.5. Oh no. Give me a second. I don't remember now. 2.5 is total defect points. Uh, 3.5 is the weighted defect quantity. Is okay, and then it is 7.5. How is 0.5 multiplied by 5. Okay. What's that? Oh, okay. Now I remember. Meaning you here, right?
Yes, I'm here.
So I forgot this equation for a little bit. Okay. It's good. If you directly consider defect rate, what is the defect rate? Defect rate means defect quantity divided by check quantity. Check quantities. So right now total defect quantity is 3, right? So the total check quantity is 20. So 3 out of 20 mean how much? Is 15%, right?
Yes. Yes, sir.
3 or 20 mean 15 or 100, yeah, 15%.
50.
15%. But if we consider defect rate in this way, it's not fair because some of the defect can be minor defect, some of the defect can be major defect, some of the defect can be critical defect. In that case, we have to wait for each defect to see how much that defect is effect to us. That's why we gave a weight like this. So the minor effect is we give only 1, but for the major defect have very high effect, minor defect. Because of that we give 1.5. Critical mean very serious defect, so we give weight as 2. In that case, we need to calculate this weighted defect like this, weighted defect rate like this. So then for that we need weighted defect quantity. We need to divide by check quantity. So what is the weighted defect quantity is 3.5. See 3.5, let's see here. 3.5, right? 2 plus 1.5 is 3.5. So then we can find the weighted defect quantity is what is that? 0.5 divided by 20. How much is this? 3.5 multiplied 5 means 17.5 divided by 100 is 17.5. 17.5, right?
Yeah, just 17.5.
Yeah. So then we can find this is how we calculate weighted defect quantity. Maybe I will write the equation here also, right? Otherwise you may forget. Weighted defect mean minor defect quantity multiply minor weight plus major defect quantity multiply major weight and if this meeting end, join again with same link. Okay.
Okay, sir.
Critical defect quantity multiply critical weight. I think this kind of formula you have to build a function. Okay, so then we can find the pass rate find like this. Pass rate is equal 1 minus weighted defect Okay, in that case it's 1 minus 70.5%, 0.175. That's mean 0.85, right? That's mean 82.5%. This is how we calculate pass rate. So this formula is clear to you, right?
Yes, yes, sir.
Yeah. So then based on this pass rate, we give a result like ABCD results. We consider as A, if this pass rate is 100%, then A. B, we consider pass rate is 95% to 100%. And if C, 92.5 to 95. And D mean less than 92.5. Less than 92.5%. So we can say if it is grade is A, it's good. That means 100%. 100% mean how many defect it can be?
Yeah. Defect.
Yeah, 0 defect, right?
Yes.
And 95 to 100, it can be only one defect. So if you consider only 20 sample, it can be only one defect in order to get B. But this one is not only 20 sample checking because they do inspection every day, right? So the same QC, QA check same QC for each and every day. So then this check quantity also going to increase, right? And the defect quantity found by QA also going to increase.
Back.
You can see the screen, right?
Yeah.
That one is clear now. The result ABCD we give like this, and this one not always 20 sample because QA check every day. So then sample size also going to increase, and the defect quantity also going to increase.
So for this, just only one report, right? For this process, we are doing in one report, and it will be the same for every report, right?
One report.
Yeah.
You mean one record? Or what?
Yeah, record. It's like a report, right? When you store the user input as the report.
Yeah, so this one is one QC only doing for one Q. Sorry, this one doing by QA. QA doing only for one QC.
Yeah.
So for in the database, in the collection, we have one record for one QC.
And it also one report for this form, right? When complete, we call this one report.
One report, yeah, one report. But this one do every day, so then we have multiple report for same QC.
Yeah.
Yeah. So then this is how you calculate this result, and then also we have a pass or fail thing. Pass or fail thing. Pass mean if this pass rate is greater than 95%, we call that report is pass. This is report result. You can say report, okay. Report result. One report result, right? If pass rate is greater than or equal 95%, we call it pass. Else fail. So that's mean in order to pass, what need to happen? They take only 20 sample, right? What condition should be passed?
Mean just only one or two defect detected.
No, two
It
defect
can be passed.
Two defect fail. Why? Use two defect, you multiply by 1, then 2, right? Weighted defect quantity 2. Then 2 divided by 20%, already 10%. So 1 minus 10% mean 90%, right? 90% fail.
Yeah. Maybe only one.
Yeah. What defect? Also defect status is also inferred. Minor, major, or critical. If it is minor, then 1 divided by 20, 95%. 5%. 1 minus 5%, 95% is fast, right?
Yes, sir.
Yeah, but it is major, then 1.5 into 20 mean 1.5. So then 92.5 fast rate is fail, right? So only there are two conditions for pass. Is either 0 defect or 1 minor defect for 20 sample size. Is clear?
Yeah.
Yeah. This is for report result. And this is for all, not only report, this is all, how can we say, all report valid. This is valid for single report and all report also. But the pass rate,
the pass rate it depend on the standard.
pass rate depend on the defect status. Yes. This three, based on the defect status, it change, right? That's why we have a calculation like this.
Yeah.
Yeah. Okay. So in order to pass one single report, that pass rate should be always greater than or equal 95%. That means there are only two conditions. One condition can be 0 defect, or other condition 1 minor defect. That's all.
So I have missed small part about weighted defeat rate. that you
Yeah.
use a check quantity as the same QA simple size.
Yeah. Check quantity mean QA sample size. QA sample size mean actually the check quantity.
Okay, sir. Got it.
Was I'm not. I don't remember which name I save in the collection. It
Okay,
can
sir.
be QA sample size or check quantity.
Yeah, we
Okay.
use 20. Yeah.
I think I use check quantity. Okay. Yes, that's same. Yeah.
Okay, got
Yeah,
it. Sir.
check quantity. Yeah. Okay. Then why this one is stuck? Okay. Okay, now there are remark section also. Here they can enter some additional comment, and also they can add image for each defect also. In your board, can you pull this image also? Can you show that one or cannot?
If you have image link, we can show it.
Oh, that's mean you can show it. Okay. So this now I will show you this collection how we sales data. QC accuracy. Oh yeah, this one. Okay, we saved the data like this. This single document, single report means single record means it has date and then report type, style, color, line number. Can say like this. Collection. Okay, I will copy the collection name also. QC accuracy report. In this collection, we have one record, one document for like this based on inspection date. QC ID also there. Let's see. Okay, this one. Okay, fine. We have one record like this. One inspection date and then report type, MO number, color, and QA ID and QC ID. We have one report, right? And in the collection, we save data like this. So we have date and then QC inspect this one. QC data, we use object. So we have employee ID and the English name also. So then scan QC, we have employee ID and English name. So we use object for that. And then report type, then style number, color we use array, but here we always have only one color. They select one color. So even if it is array, you will see only one color. Size, maybe this is option. So sometimes you will maybe not see the size. But I can see the select size also here. But this is array. That means in the 20 sample size can have multiple size. But this is not important. I think even you can neglect also. Try to include that one, but not important. Okay, then line number. So the table number you see is NA. Why? Because the report type is inline solving. That means we have line number, but we don't have table number. Because if the report type is QC1 inline solving, that means it coming from solving line. Then we have check quantity, and then we have AQL thing. This AQL is not, we don't use this. There is something called AQL also. I will explain in another collection. But for this one, we don't need this one. We don't need this one. But this logic actually coming from the AQL. We said this in order to pass one report, it should be either 0 defect or 1 minor defect, right? It actually coming from AQL. There's a logic called AQL. I think you don't need to use this one for this report. So you can neglect AQL thing. And then defect. In defect, we use array. In that array, we use one object for each defect name. Right? Here we divide like this, right? Garment 1, defect 1. Then we can add another defect for same garment. So garment 1, defect 2. Now 2 object, right? If we add another pieces, garment 2, defect 1. Now there are 3 object. So in that object, you can see the pieces number and then defect code. This is related to the defect name. Each defect name we have defect code. Then you can see the English name, command name, and Chinese name also. Then you can see the quantity of that defect and the decision. This decision need to select by QC, and then you will see the standard status. That is the status coming from here automatically. Based on decision, this status come automatically. Then you will see there's another thing called type. This one actually the one we call buyer status. For your chatbot, I think you can neglect this one because we consider based on the standard status. The buyer status means it's something like this. We have 5 buyers, right? As I explained at the beginning, we have 5 buyers. And also we have list of defect name. Like we have, let's say 50 defect name. This 50 defect name status change based on the buyer name. We call it as buyer status. For example, if we consider skip stage, it can be a minor defect for Costco buyer, but it always major defect for RECR buyer. Based on the buyer, this status is changed. Mian, is clear?
Yeah, got it, sir.
Yeah, but if we consider that, so then it unfair for QC, right? Because same defect, QA found same defect, but because of 2 buyer, we consider is minor and major 2 status. If we consider like that, it's unfair. That's why we consider standard status. We have 2 collection for that. I will show that one also. Okay, but this type mean this is buyer status. Don't neglect this one. You can get this one also, but not important. Then you can see image URL. For each defect, we have image URL. If user add image, you will see URL here. And then
Therefore, image URL is the public source, mean not the directory path, just URL that can be yes.
yeah, URL. Just see, you can find anything.
I think for the calculation may be optional because you already store the result in here. When the question will ask, the bot will search the result from the collection.
Yeah, this for the single record, you can get the status like this.
Yeah.
But if you consider multiple report, what you need to do, you need that equation, right? To get how many sample pass, how many sample fail, you can use this collection directly. But if you get
count of it.
pass rate, then you cannot do this.
Got it.
Yeah, because this is only for single report. This actually 95 only for this report. But if you consider two report, then you cannot add these two and divide by 2. You cannot do like that. You have to use that formula. Understand?
Got it, sir.
Yeah. The image, you will see image URL like this. We have we have this link, right? It will be this link, and after that something, some numbers and dot.
So the image will store.
We save it in production server.
So we have another storage to store the image, right?
Yeah, but we save in the same production server where our backend control.
Yes.
Yeah. Okay. I think that's all about collection. So for the single record, you can get directly whether it is pass or fail from the directly. But when you calculate pass rate, you will need formula. It's okay, right?
Yeah. Got it.
And then I will show you the QA standard defect collection. QA. Now this one. This is our defect collection. Standard defect we call as standard defect because we get the status from here. You can see that one we have 3 names, and the decision there is array. So in that array there is object for each decision. Based on this decision, we have status major if this decision is critical. Okay, and each defect we have code. Let's see 1 to 110 like that. That is defect code.
Yes.
Yeah. And also we have other status, but that one can neglect bias status. Okay. Yeah, QA defect. Okay, this is our other status. Other, you see there's a status called type right here. In the defection, you can see there's something called type, right? This type is coming from this QA defects collection. QA defect collection. In that collection, we have a defect name, all 3 names, and then we have status of buyer. We have 5 buyers, right? So on each buyer, you can see one object. For the Costco buyer is always, you see, is common. Field is major. We get this is common for this biostatus. It can have multiple status here also, but QC never change this. When they do this code, you see this biostatus, they can change, right? This one, but they never change. So it's not correctly display the status because of that. Okay. This collection is
Yes,
okay
sir.
for you?
Yeah, yeah.
This is not important, but this QA standard defect is the one we consider. And then the report is QC, QC accuracy. QC accuracy report. This is the one you need to consider. Okay, then in your chat board, now can create based on this. So how are you going to create this? So first you need this data pre-processing part, right?
Now I have a keyword description that I can train bot to clearly understand that and easy to query later.
Mm-hmm.
And now I plan to use Rasa Pro on that. We'll use LLM to generate response that is better than the one I built in BioAI.
Mm-hmm. So in your chatbot, when we ask a question like, I will show you the result section. So this is result section, right? If
Yes,
I
sir.
ask a question like this is QC ID. So I ask question, give me QC. No, not only ID. You also need to consider name also, right? QC name also, because
Yeah.
the user can ask by name, right? They may not remember ID. So if I ask this QC, give me last week, I can ask question like last week fast rate. What is the fast rate? Then you should be able to query the last week mean today to 7 days before, right? Then
Yeah,
you
yeah.
need to consider last week, and then you need to capture all of this. You need to map all of the records in the MongoDB collection, and then you need to calculate these values. You can get this sum directly from the collection, right? Check continuing this, you can get sum of this 20, right? For week, and then reject visas you can directly get. Then these values you should have pre-processing part, because I don't store minor, major, critical in the top level. It is inside of this object. See, the minor is one quantity for this object. You will need pre-processing part for that. And then you should be able to show that this is the pass rate. Why this one happened? Because there are 5 defects based on this category. Then it is better you to show what are the defects found that time level. You can show so many things also. Okay.
Yes, sir.
Yeah. So now it's you clear about this, right?
Yeah, yeah.
You have access to this database.
I have cloned it to the deals over database.
Okay, you can use this collection, these two collection. Okay.
Okay, sir.
Yeah. So then get JSON. If you already clone, it's okay. So then directly use that one. Okay, try to build this one first. So then you are going to build this in Python first, right? You can
The processing will be in the Python. And I will connect to the our React.
Yeah, first and try to build in Python, and also you can ask the question in the terminal, right? So then you can see its answer is correct or not, right?
Yeah.
Yeah, you can always use this web to check answers correct or wrong. Try to build this up. This is the result section. So then if I ask a question like this, so then you can see whether it is correct or wrong from here.
Okay, sir.
Okay. Okay. I think that's all. You can start working on this from today.
Okay. Thank you, sir.
Okay, bye.